welcome to my YouTube channel. In today's video, we will see how we can design a pulley and its support assembly. I have also made a drawing with the dimensions of all the parts. We will make a 3D model and see how we can assemble all the components in this video. Let's start by creating a new assembly. So we don't have any files as well, so I'll save it as pulley as an assembly. Okay. So now we have got our assembly files. So first we will go ahead and create the base plate. So what I'll do, I'll create a new path. I'll go to path. I'll take the top plane. I'll go to features, create extrude. So our base plate is going to be a rectangular plate. I'll take this dimension as 150 and this dimension as 100. I'll make it 12 mm thick. Okay, so we got the plate. Now let me go ahead and create holes on this so that this can be we can mount the brackets on it. So I'll go to hole wizard. First I'll define the positions. To start with the hole, you can just create 4 points and you can say this and this. So these 2 points are symmetric about the center plane and these 2 points are symmetric about this particular center plane. And if you see, this is free. So how are we constraining it? So I'll say these both are horizontal to each other. This is going to be horizontal to each other and this is going to be vertical. This is going to be vertical. So now it is aligned. So I can start a dimension. I can say this is 50. I'll say this dimension is 70. We can edit it later based on our thing. Okay, so one more thing we have to check is type of holes. So I'm going to mount my brackets, support brackets on this. So I'll take a tapped hole, let it be M6 and give OK. So now flat plate is created. This will form the base of our component. I'll save it. We'll save it as base. The first part is ready. The next part that I'm going to design is the bracket. So I have the dimensions here. So it's going to be L-type bracket. We can make it out of sheet metals. So this is the final dimensions. We will create it with the relevant dimensions and later edit it based on our assembly. I'll create a new path. I'll go to sheet metal. I'll create a base flange. I'll take the top line. I'll say this width is going to be 70 mm. Just let me make it as 50. We can modify it later. Make it as 30. I'll exit the sketch. It will ask what is the thickness, so I'll keep it as 5 mm thick. Yeah. Now what I can do is I can select this edge and then I can create an edge flange. So I'll click this. I'll click this feature and I'll say this length is 80 mm. We can edit it later based on our requirement. So now this is done. So now I have to make 2 holes so that I can fasten this bracket and I can make a hole here so my pulley can be attached here. So first I'll go ahead and I'll create a hole feature. I'll create a hole using hole wizard. So let me define the position first. I'll select point 1 and point 2. So I'll say these both are vertical, and I'll define a line horizontal at the center. So this is basically to define that this particular hole is symmetric with respect to the center plane. So I've made it symmetric. Now only two dimensions we have to give. So one is x and another one is y. So x dimension, let me keep it as 20, and this center distance we can keep it as 50, which we have already done for the holes in the meeting component. So this is done, and before doing it, this is not a tapped hole. So this is going to be clearance hole. So I'm going to select this hole option, and then I have to select screw clearance from the drop down here as type. So then I will choose M6 and click OK. So now it is done. Up next, what I will do, I'll go to sheet metal. I can create this feature with hole wizard. I will also give you one more option. I will explain about one more option. You can click here and you can go to simple hole, which is here in sheet metal. So simple hole, it will define a sketch, and then here you can say link to the thickness. So it will be through hole, which is linked to the thickness. You can exit the sketch. Now to edit the position, you can expand this feature and click on the sketch, right click and click edit sketch. So now to define the center, what we can do is we can take the reference of this plane as well. So we can take this plane, and this one is going to be coincident. So that way also we can do it, or else we can draw a line and then make it coincident. Next up, I'll take this dimension to this. This we have already seen it in the drawing. So this dimension is going to be 65. Any dimension you make it here, you'll be able to edit it. It shouldn't be issue. You can do it at a later stage also. So this I will have it as 15 mm. So a hole is created. Now what I will also do is I'll create a fillet here. I can also create a chamfer. So generally for sheet metal, we create this fillet because it gives a good appearance. So generally sheet metal parts are made of very small thickness as well, less than 1 mm. So in that case, in the drawing, generally you give as break all sharp corners. So all the sharp corners will be grinded so that it won't uh, cause any damage to your skin when you're handling. So this I'll save it as support bracket. So now my second part is ready. So this is done. So next what we have to create is pulley. So I'll create a new part. We'll take a front plane for this. We'll go here and we'll say revolve. So I'll define a center line first. We'll say it's horizontal. We'll click this. So center line is defined. Now what I can do is I'll start with a straight line. I'll go up here. Then we have it horizontal. Then we can come down. Okay, I'll leave it up to this. What I will do is I'll draw one more vertical line. So I'll mirror all these entities about this particular line. So now it is mirrored. What I can do is I can just select a line, connect it, connect this. So I am having a gap is this at the center we need a hole. So I'm creating gap for defining the center. Since it is symmetric revolved part, it is better to create a diametrical value. So this I will have it as 20, and this I will have it as 90, and this value we can have it as 60. We will have it as 70, and this we will say this dimension is 2 mm, and I will also say the width is 30 mm. Okay, now you can see in the sketch these particular lines appear black, whereas this line is appearing blue. The reason is it is under constraint, so you can move it. That is why it is appearing blue in color. So this width we are yet to constrain. So I'll go to dimension, so I'll dimension it as 15 mm. So now it is done. All the entities have turned black, which means it is constrained. So I'll exit. It will ask me the center plane of revolution. Only if there is only one center line, it will take it as the default plane. Now, since we have two center line, it's basically asking us to choose a plane to revolve. I'll choose this plane, so it is revolved about 360 axis, 360 degree. So now this is done. So we got a pulley. Then what we should also do is we should add some fillets here. I'll click fillet. I'll choose this edge and this edge. I'll say the value is 5 mm. So this gives a really good finish on the component. What I can do is I can add a chamfer here also. Here. This will be practically done because any component that you manufacture will not have a very sharp edge. Okay, so this is done. So we have made our pulley. So I'll save it. I'll save it as pulley. What I have to do is I have to apply appearance for each material as well. So I'll right click the part. If you can see appearance drop down is here. So I can click this particular part. So this opens up the appearance window. So I'll choose a metal for this. Let's say this is made of steel. So I'll find the finish here. So it's going to be machined steel. So this will give me the appearance of a machined steel. But color, it's up to me. I can choose a color. So I'll choose a light yellow or a darker yellow. I'll choose this light yellow. So if you go to this realistic view, it will give you a really good appearance similar to the component. So I'll turn this off. This will if you are in realistic view, it is going to consume a lot of computing resource. So you can turn it off when you don't need it. So I'll save it. So this is saved. So almost all the main parts are done. One more part we have to do is pin, which connects the pulley. So I can start a part. I'll go to revolve. I'll use revolve command. So for this, I'll define a horizontal plane. Let's make it infinite. I'll click it here. Okay. So now the center plane is created. What I will do is I'll start from here, or I'll start from this point straight up. This is going to be the head of the pin that we are going to design. I'll extend it. Then we have at the end we should have a thread or a hole, which I'll tell you later. So now let's define the dimension. Let's say this length is going to be 80. We can modify this length later as well. So say this dia's going to be 30 mm, whereas this dia is going to be 15 mm. Let's say this width of this head is going to be 5 mm. So that's it. As I told, since there is only one plane, now it is revolved. So now pin is also created. I'll save it as pin. What I can also do is, so this is 15 mm. I'll create a extrude cut to define the threaded portion of this pin. So let's say we'll have an M10 thread. So I'll make it 10 mm. I can exit the sketch. You can see I can flip the side of cut. So the external portion is going to be cut. So let it be 10 mm. We can edit it later accordingly, according to our needs. I'll go to our assembly. You can press Control Tab to shift between tabs. So this is our assembly. I'll click Insert Component. First thing that we have to bring it is base plate. So it's here. So first part will be default. By default, it will be fixed. So I'll bring in the next part. So that is our support bracket. Okay, so this is the place. So what I will do, I'll edit the mates. So I can clear this. I can select this face and this face. So I'll give coincidence, which means this face and this face is basically touching each other. So I'll give OK. Now to define, now if you see, this part can move. It is free to move and it is free to rotate. So to arrest that, what I have to do is I can make this particular hole and this particular hole coincident. So I'll click this, I'll click this. So it is taking concentricity mate. So there is one more option here which is given as lock. So what will happen is if we give lock, the component will be locked from rotation. So but generally if you see, I have given coincident, so it has fixed the z axis. Now I have given a circle, which means this part can rotate about this axis. So this is left free. So to constrain that, what I will do, I will select this hole and this hole. So again, this is made concentric. So now this part is completely defined. If you move, it is not going to move. What I will do, I will just press Control C and Control V. So this part is created. Just copy it. So I'll go to mates. I'll repeat the same. Click the surface. Okay. So this lock is enabled. So I'll make it concentric or a coincident. I'll say this, and this face has to be in line. So I've given S. Now what I'll do is I can move this here, like concentric. I can choose this and this. So now this is made concentric. So I'll rotate this part. Again, I will choose concentric. Say this and this particular hole is in line. So these parts are defined. So this is clear. Now what I will do, I will bring in the pulley. So pulley I have take. You can use this option here. You can just give a rotate so that component can be rotated. rotated, it will be bought in the default orientation. So click here. So to define this, again we have to define, we have to constrain all the 3 axes. So first up, I'll give concentric. So this hole and this hole is going to be in line. So concentric is given. Now I can give log rotation. This will log this part from rotating about this axis. So it is given. Now I will use one advanced mate. So what I'm going to do is, this particular part is going to be aligned exactly in between. So I'll go to advanced mate. I'll say I will use with mate. So for with mate, what you have to do is, you have to select 2 faces for your reference and 2 faces of the component that is going to be assembled. So as you can see, it is perfectly aligned. As you can see, it is perfectly aligned. So that's it. So this is aligned. Now you can see the width of the pulley is, you can select this face and select this face, it will be displayed, it is 30 mm, and the width between the bracket, it's again 30 mm. Okay. So now if you see the diameter, it is actually 20 mm. This is for a specific reason. I'll tell you. So now what I will do is, I'll section this. As you can see, I have sectioned it about the front plane. Now you can see these 2 parts are aligned, and now you can see these 2 parts are aligned. So the diameter is different. So this radius, if you can see, it's 7.5, whereas this radius is 10. So there is a reason for it. So whenever you have a pulley, so this pulley is going to be rotated. So when it rotates, it's going to create friction between the components. So to handle that, generally we use a bearing or a bush. So if it is a high pressurized application or something which should produce no noise, we go with the bearings, whereas a bush will be used in a much simpler application where accuracy is not a key thing. So right now what I'll do is, I'll go out of this sketch. I'll assemble the pin as well. Pin is here. So pin, if you can see, it is 15 mm. This is also 15 mm. So I'll assemble the pin here. Clear this, make it concentric, this and this. It's going to be concentric. I'm going to lock the rotation and say okay, and select this face. It's going to be coincident with this face. Okay. So it is done. So 2 things I have to do. One is, I'll design a bush now to place it in between. So I'll start a new part. I have started a new part. So then, since this is again going to be a thing which is similar to the pin, I'll create with the revolve. I'll choose the plane first, horizontal, vertical, horizontal for construction and infinite length. I'll mark this one. So to create the bush, as we did for the pin, we can start just above this. Then we can define this thickness, go down, this, and this is going to be connected. So about this center plane, when we revolve, we will have a diameter. So I'll choose this, and I'll say the diameter is, as we have seen, the diameter of pin is 15. So I'll keep it as 15. And the hole which is in the pulley is 20 mm. So I'll leave it as 20. So this thickness, I can have it as 5. So we'll have a defined length. And this dia, we can have it as 30. So I think we didn't define the length, so it is done. So let's go back and edit the sketch. If you see, this is blue in color, which means it's free to move, so we have to constrain this. So I'll say the entire thing is about 15 mm. So 5 mm is the head, then 10 mm is the base. So this is done. I'll save it. I'll save it as bush. Always a bush will have an entry chamfer, and that should be at an angle of 30 degree. So it's going to be 1 mm. It's not going to be 30 degree this way, it has to be flipped. So this will help you in easy entry of the bush into any component. So here also we'll add a chamfer. Here also we'll add. This is going to be normal chamfer. It's going to be 45. Can make it as 0.5. Okay, so part is ready. I'll give an appearance for this. Bush. Choose browns. Okay. So bush is done. So I can close this. Insert component. If that particular part is not open, it won't be displayed here. What you have to do is you have to browse and then go and select the part that you want to insert. So this is the bush I want to insert. So I'll click it here. So one more thing I just want to tell you is, in case if you're bringing a part which is down here, but you want to make it before some assemblies, what you can do is you can just click this and you can just drop it just where you want it. Okay, so this is one way of reorganizing the tree. So in case I don't want this pin to be shown now, so I can just directly hide it. I can edit this. Let's clear this. I'll say concentric. So it's going to be concentric about this pulley. Selected this. We'll lock the rotation. Click OK. Then this face is going to be aligned with this particular face. So it is done. Okay. So to make it easy, what you can also do is you can hide this as well and hide it. So this will give you a better view. Now again you can copy this bush, paste it here. This bush also you can move it before the pin, and now you can edit it. Let's clear this. We'll say concentric. I'll say this face, and this has to be concentric. So now it is here. So to change the orientation, you can just click and alignment. So this is going to be rotated and it is aligned. So now you can click lock rotation. So now rotation is locked. So now we can go here, select this particular face, and you can choose this particular face. So now it is aligned in place. So this is done. If I show the pin and the support bracket, so it is done. Okay, so now I'll give you some more details. You can go to section view. So this will be helping you in viewing components which is on the inner side. So this will give you a real good picture. As an engineer, you will know about this. So now you can see these two components are interfering. To adjust this, what I have to do is I have to move this brackets apart so that it will be adjusted. So as you know, this bush dimension that I have created is flange thickness is 5 mm. So it's 5 mm. So per side it has to be adjusted by 5 mm. So this is our base part. So it's here. I will directly edit it from the assembly. So I can expand the tree, and this is the hole that has to be adjusted, because that is the hole we have aligned this bracket with. So I'll select the sketch. You can choose edit sketch, and so you can see it is edited in the assembly. I'll give it as 80. So each side 5 mm, so it is 10 mm altogether. I've done it. I've closed the sketch. I've come up. Now you can see this bush is here. So next thing that I have to do is I have to flush this to this surface. Directly you can see the dimension is 15 mm. You can also go to evaluate and use measure tool to get this dimension. So this has to be 15 mm shorter. So what I'll do is I can also directly edit it from here. I can directly double click this, so it will show me this dimension. So this is basically 80 mm, so I have to make it 15 mm shorter. So I'll click here, say minus 50. One big advantage that we see in this software is we need not use a separate calculator. It does all the mathematical operations here. So I'll rebuild it. So now you can see the component is aligned. What I also see is this particular part is very close to the top, so I can also edit that. I'll expand this. So we created it with a simple thing. You can directly edit the sketch by editing by going to edit option. In case it's a small dimension, what you can do is you can just double click it. It will get you into the document, or else it can show you that dimension as well. So I'll give 60, so it is edited. So I'll exit the sketch, exit the assembly. Now you can see it has come down. So now I will assign some appearance for this. That can be done from assembly as well. So that is why I didn't assign the colors in the part directly. To collapse this tree, you will have an option here. I'll collapse it. And now I can directly click that part and choose appearance. Here there are two options. So this is to apply the appearance at a part level, and this is to apply at an assembly level. So if you apply it at an assembly level, what would happen is it will be as visible only in the assembly. When you open a part, that particular color won't be there. So now I will apply in the part level. So I'll go with dark gray. This is done. So this part also I have to apply color. So if similar parts are there, one part if you apply, it is going to be reflected in other part. If you give the appearance at part level, if you are going to give it at assembly level, that will be applicable only for that particular part. So this I'll choose a different color, maybe somewhere red. Okay. Generally, we don't prefer red, because any component that is not aligned properly or have some mate issues, it would be showing red. So we will give some other color. So here it is, our pulley assembly is almost done. So this pin also we have to assign appearance. So this pin is going to be hardened steel. So we'll make it off. We'll give a matte finish to it. We'll say the color is gonna be, or else I'll leave it like this. Looks good. Okay. Now we section it. You can see how our pulley assembly is done. So this would be easy to assemble also. So now if you see from a engineering perspective, this pulley should only rotate. It shouldn't move to the left or right. So we have to constrain it on the revolving axis. So that we have done with the pin. First we have a pin. So on this pin, this bush is there. On this bush, this part is there. So it is only allowed to revolve around it. It cannot move anywhere. And second thing is, from this axis, if you see, I'll shift to the front plane. So from this axis, if you see, it shouldn't be allowed to move towards left or right. How are we doing it? We are having a bush with flange head. So this will help this component or arrest this component from moving to the left or right, and this bush is going to be arrested from moving to left or right by this bracket, and this bracket is going to be fixed. To constrain this pin, now if you see the pin, so I think the only the pin is unarrested. Pin, you can have a washer and a bolt here, or else what you can also do is instead of having a threaded one, you can drill a hole through, you can have a cotter pin. That would also help. And a fastener, what we have to do is, I have the toolbar here. So if you can see the toolbar, I'll go to unsymmetric. And you can also select it here. You can see socketed cap screws here. So before assembling the screws, we have to go and find out the washers. So I'll go to washers. I'll take plain washers. So I'll take the regular flat washer. So what I have to do is I have to pull it to this particular location. So now you can see it is getting aligned, and we have an M10 size and it is aligned. So I can click OK. So I don't need any copies, so I can close this. I can do is I can pull one more washer and blend it to this hole. This was M6. I'll choose as M6. Okay. So I can place it here, here, and here as well. So component is inserted. Now I have to choose bolt. So I'll use socketed cap screw. I'll pull it. I'll just directly drop it on the washer. So now you can see it is selected as M6. In case if you want a different thing, you can choose it here. And the length also you can choose. See now this is 5 mm thick, and you will have 1 or 2 mm thickness here. So it is 10 mm. So 6 mm is already gone. So you can make it as 16 mm. And you can see the bolt is coming up with this. You can even make it 20 mm also. So now it is protruding. So 16 will be a good. So okay. So you can place it here, here, and this location. So now this particular component is completely fastened. I can also add a bolt to it. So go to unsymmetric. I have nut. What I will add is I'll add one nut, and then a lock nut also I will add it. So M10 nut I have added. This is done. I can close this. Yes, I can delete it. Generally, for tightening, in order to prevent it from loosening over time, we need to add a lock nut. So that's a good practice. So I'll go ahead, or what I can do is I will assemble this thin nut, which is called a jam nut. I'll assemble it here. So it is done. So I can see the difference. So it is 6.2 mm. So I have to increase it by 6 or 7 mm. So I'll make it 10 plus 8 mm. I will increase it here. And overall length I will increase 8 mm. So I'll click plus 8. So now I'll go back to that assembly. I'll save it, rebuild it. Okay. Now if you take a section view, you can see it clearly. So this pin is here. So I have a washer and I have a nut, which is a basic nut, and then I use a jam nut. So adding a jam nut would prevent it from loosening over time. You can also add a serrated washer or a lock nut, a lock washer here. That's it, guys. That's it for today's video. I hope you liked it. Please comment and give a like to our video, and let us know in the future if you need some other mechanisms or things to be developed in SolidWorks or technically.